Now that we've seen the consequences of what happened and how the plant operated on a daily basis, let's discuss what went wrong. Well, the list of what went wrong at Bhopal is quite long, but the basic scientific explanation is that somehow water entered a tank containing methyl isocyanate, MIC. The water and the methyl isocyanate reacted exothermically, causing an increase in temperature and pressure. This increase was so great that the methyl isocyanate expanded into a gas form, blew past all the safety systems and was vented into the atmosphere. There's been 3 major investigations into the incident at Bhopal. The Indian government conducted its own investigation through its Central Bureau of Investigations. This report has never been released to the public. Union Carbide conducted its own investigations, and an independent investigation was conducted by an engineering consulting firm, Arthur D. Little. All 3 reports agree that the cause of the incident was water entering MIC storage tank 610. However, the reports disagree on how much water entered the tank and how the water entered the tank. The Union Carbide report and the Arthur D. Little investigation suggest that the only way enough water could have entered the tank would have been for it to be deliberately poured in by a disgruntled employee. The Indian government report has never been publicly released. However, the Indian government has supported the theory that the water entered the tank when a section of pipeline was being washed. The initial investigations were hindered by the fact that large amounts of toxic chemicals remained in tanks and had to be neutralised before the investigations could take place. However the water came to be in the tanks, the fact remains that the plant was poorly designed and located in the first instance. The plant design was compromised from the beginning, with the local government authorities insisting that the latest technology electronic warning systems be replaced by analogue gauges so that more employees would be required at the plant, thus providing more employment opportunities for local people. The location of the plant, so near a large population centre, was also raised in Parliament. However, influential politicians with monetary stakes in the pesticide plant dismissed these concerns. The pesticide plant had been running at a loss for some time before the disaster, and many areas of the plant had been forced to cut costs. This cost cutting resulted in a reduction in staff training, a reduction in maintenance on the plant, a reduction in the amount of vital spare parts kept on site, and a reduction in personnel. Many of the plant's experienced personnel had also left the plant for better paying jobs elsewhere. As a result, on the night of the disaster, several safety systems were not in operation. A refrigeration unit designed to keep the MIC at low temperature so that the likelihood of a runaway exothermic reaction would be reduced had been shut off. A gas scrubber that was designed to neutralise any MIC gas that escaped the tanks was shut down for maintenance, and a flare tower that could burn off escaping MIC was offline awaiting a replacement part. A water curtain supposed to spray to the top of the flare tower was poorly designed so that the water could not reach the top of the tower. And even though the factory was located so near a large population, there were no operational warning systems and emergency management plans in place. This resulted in a chaotic response and increased the magnitude of the disaster. The tragedy at Bhopal was not caused by a single failure of one component, but by a chain of events. There was a systematic failure in equipment, personnel and procedures. The failure started at the design process and continued through the operational phase until at the end most of the personnel were as demoralised and broken as the equipment itself. Our team will now discuss what technical improvements would have prevented the disaster and what lessons can be learnt from this tragic incident.